Good afternoon. I'm Ray LaChance, co-founder and CEO of Zenfi Networks. Before I get started, I want to thank Alyssa and the NEDAS team for the opportunity to participate as a keynote speaker at the virtual symposium today. I'm both humbled and honored to be here. Today, I'm going to talk about what we and some in the industry call the horizontal tower. I'm not sure who coined the phrase first, but we've been using it for years and it may have been first. Although I think Jay Brown at Crown Castle and Mark Ganzi at Digital Colony might contest that claim. But hey, as they say, imitation is the sincerest form of flattery, and it makes me happy to have those guys admire me like that. All right, before we jump in to more of that, I think a brief overview of our company, Zenfi Networks, will be useful to understand for context. So here we go. Zenfi is a New York-based regional communications infrastructure provider of fiber optic network edge co-location, and wireless siting solution for the mobile operators. Zenfi's infrastructure is shared across multiple customers, enabling the operators to deploy network assets more rapidly in more places at a lower cost of ownership. We currently own and operate more than 1,300 route miles of fiber optic network, interconnecting nearly 50 co-location facilities, supporting approximately 3,000 wireless sites with almost 6,000 sites under contract, including macro sites, small cells, and end-user buildings. It's been about 6 years since we started the business, and we're certainly proud of those accomplishments, but we think it's just the early innings, and there's a great opportunity to move forward. These are clearly interesting times, both for our industry and personally, as we navigate through the new world order of entire companies working remotely, homeschooling our kids, and even participating in the conference circuit while sitting in our home offices like I am today to record this message. Those of you that know me know that I often participate in industry conferences as a panel participant and sometimes as a sole speaker. This is my first time doing a pre-recorded video keynote, though, which, to be honest, is a little disconcerting. I'm finding having the opportunity to sit in front of the computer with the video running, looking at myself to record the message is both a blessing and a curse. The blessing is I get to do do-overs for mistakes. And of course, the curse is I get to do do-overs for mistakes. That said, I truly appreciate the opportunity to speak with you today about a topic that my team and I became fascinated with 7 or 8 years ago when we were thinking new business ideas in the telecommunications asset space. It's always fun to come and talk about what's next. And when Alyssa offered the opportunity for this keynote, I felt it might be interesting to discuss how we at Zenfi Networks view the mobile wireless ecosystem today. Before I dig into the headline topic, the horizontal tower, a key enabler of 5G, I think a little background would be helpful to set the stage for the discussion. Almost 20 years ago, I was fortunate enough to find myself as CEO of a regional fiber provider, Lexington Metro Connect, based in New York City. Lexington was a dark fiber provider focused on providing fiber circuits to the usual suspects, large banks, media companies, schools, hospitals, interconnecting enterprise buildings to enterprise buildings to data centers, and data centers to data centers. A traditional backhaul fiber business. In hindsight, legacy was a legacy backhaul fiber provider that solved for what I now call a sparse networking problem with high capacity fiber optic cables interconnecting sites few and far between. These backhaul networks are just as important today as they were 10 or 20 years ago. However, we have a new problem to solve for as the wireless industry evolves from 4G to 5G. In 2014, when we launched Zenfi, we started building fiber optic networks around New York City. Our peers in the industry thought we were just building another fiber business like Lexington. However, we had a very different plan to build an underlying wireless infrastructure business that not only provided fiber circuits, but solved for the complete end-to-end infrastructure needs of the mobile operators. When we began using the term horizontal tower to describe what business Zenfi was in a few years ago, it was not just to be opportunistic and partake in the stratospheric valuations afforded to the tower companies, although we'll take that all day long. At the time we were starting up, we were seeking an opportunity to build a business that would support what we believed would be one of the greatest growth areas in telecommunications, providing turnkey infrastructure solutions, supporting the mobile operators as they densified their 4G networks, while providing a path forward and evolving to ultra-dense 5G networks. So as I said, we'll take the comp and believe it's completely appropriate since we're building a collection of hard network infrastructure assets similar to tower owners that high credit quality counterparties like mobile operators are willing to sign long-term leases with escalators to use it for 10, 15, or 20 years or longer. Setting aside the massive asset class growth and financial opportunities, I'll describe why our product offerings and solutions are more like a tower company than a traditional fiber provider, even though providing fiber networks is a core fundamental element of our business. Our thinking at the time was that a convergence theme in the telecom industry needed to play out between wireless network, wireline network, and data center operators. In 2020, that convergence is evident to everyone. But 6 or 7 years ago, I was always perplexed that that the so-called fiber and data center companies weren't showing up at the wireless conferences, and conversely, the wireless crowd wasn't showing up at the data center conferences. Today, the lines are blurred, and it's clear that to be competitive in the communications infrastructure space and provide solutions to mobile operators, you must provide end-to-end infrastructure that includes fiber optic networks, network edge co-location, and wireless siting solutions for small cells and macro sites. Please note that I'm using the term small cell loosely to capture the whole class of low-powered sites being close to the user, including actual small cells, mini macros, remote radio heads, DAS remotes, and Wi-Fi access points, etc. As we all know, 5G promises high bandwidth delivered at low latency with quality of service and class of service controls that will enable applications we can't even imagine today. To deliver on the 5G promise, operators need to add capacity to the network, and there are 3 primary ways to do this. 1, by buying spectrum, CBRS, C-band, 28 gig, 39 gig, check that box. Making spectrum more efficient, 5G's OFDM modulation technique makes that, or checks that box. And then there's thirdly, densifying or adding more cell sites to increase the amount of available capacity in the network. With hundreds of thousands of new cell sites planned throughout the US, and some estimates reaching 800,000 sites in the next 5 years, clearly this massive undertaking is still a work in progress. While operators and equipment manufacturers tackle the spectrum and modulation techniques, shared communications infrastructure providers like Zenfi, Extenet, and Crown Castle are working on building out the physical infrastructure to support the mobile operator needs. So what do we mean by horizontal tower? Well, we often use that term in 2 ways. In one use, we use horizontal tower as a proxy for the entire mobile communications infrastructure ecosystem, where the network of all mobile infrastructure assets is the tower of the past. In a more literal interpretation, the horizontal tower is the corollary to the vertical macro tower, where the baseband units on the ground are connected to the radio heads vertically a couple hundred feet in the air. So just pause for a second and visualize those same elements, baseband units in a neighborhood co-location facility connected via front haul fiber optic cables, running through the streets to a small cell or radio head mounted on a lamppost, street furniture, or building facade, tunnels, or even on every floor of every office building. Again, try to visualize that same technology deployed vertically at macro tower site, except laid out horizontally throughout a neighborhood, a city, a suburb. And there you have it. That's the horizontal tower. It's genius, right? To further the analogy to the distributed RAN macro tower model, those neighborhood co-location facilities, like tower sites, are connected back to the carrier's mobile switching center or command and control via high-capacity fiber optic networks. One of the ways network operators are coping with the reality and preparing for the future of 5G is to transform the radio access network by centralizing its high-cost, complex elements in the cloud and distributing low-cost elements any and everywhere its users are using small cells. This cloudification of the RAN, commonly referred to as C-RAN, will ultimately increase the performance, enhance flexibility, enhance the services, and reduce overall costs, both CapEx and OpEx. To adopt C-RAN technologies, the network operators require a completely new underlying transport and co-location infrastructure. Before we jump into the infrastructure piece, let's take a step back and describe what C-RAN technologies will do in a 5G world. To understand C-RAN architecture, let's first review a typical distributed RAN architecture. In a distributed RAN, the costly base station components and routers are located at each cell site. In this case, the baseband units and remote radio heads are interconnected via a protocol like CPRI or others that run over front-haul fiber circuits. Wireless signals are processed by the radio head, and the signal is passed on to the baseband unit to process calls and forward traffic to the mobile core via an Ethernet backhaul. In contrast, the same technologies are used, except the baseband units are relocated from an individual cell site to a neighborhood co-location facility, network edge co-location, which can be up to 20 optical kilometers away from the remote radio head. With the costly baseband units or routers centralized and the remote radio heads distributed, the mobile operators can simplify the network and scale while lowering overall costs. To support this technology evolution towards C-RAN and 5G, the underlying physical space, power, and connectivity infrastructure must mirror the higher layer software and hardware architecture. When I visualize the C-RAN infrastructure, looking from the edge inward, each small cell in the neighborhood is connected to a network edge co-location facility by front-haul fiber. The network edge co-location facility is then connected to the mobile core via traditional fiber backhaul technologies. I like to think of it as a network of neighborhood networks, where the network edge colo is really an edge data center, initially serving mobile baseband processing, and then ultimately evolving to a neighborhood compute and caching location that will be leveraged to support localized, high-capacity, low-latency applications in the future. As I stated earlier, legacy fiber networks supporting the mobile operators were built to solve a completely different problem, a sparse networking problem. Those networks connecting the macro sites to the mobile core were built with high-capacity, redundant backhaul cables, but were meant only to interconnect relatively sparse endpoints to the network. The backhaul network is a piece of the puzzle, an important piece, which we will continue to use, but the front haul network is the new parallel network infrastructure providers need to build to support densification. Since these backhaul networks were not meant to be fragmented and accessed every couple hundred feet, they can't support the demands of the operators to densify the networks. In an ultra-dense urban environment, New York City, for instance, mobile operators plan to place small cells at almost every intersection, as well as mid-blocks across all 5 boroughs. In Manhattan, which has over 3,300 intersections in a very small footprint, those small cells can be as close as 100 to 200 feet apart. So how do we get from the backhaul networks of today to the front haul networks we need for tomorrow? First, let me reinforce, all fiber networks are not created equal, and the legacy backhaul networks are not forward compatible. What I mean by that is they can't be retrofitted to become a front haul network. While there is already a lot of fiber deployed in the city of New York, a city like New York, the only way to solve this problem is to build out new front haul fiber networks using new techniques and new technologies. The new front haul infrastructure is being built with high capacity specialty cables ranging from 288 fibers to 1,728 strands or more. But unlike legacy backhaul networks, they are highly accessible, enabling closely spaced laterals and interconnecting densely populated small cell sites to their network edge co-location centers. So what am I saying here? What message do I want to leave you with? The only way 5G promises of high capacity, low latency connectivity, enabling applications we can't even imagine today, is if Fiber-based architecture converges where you take the fiber and you connect it to the macro sites, you connect it to the small cells, you connect it to the Wi-Fi, and you bring it back to common aggregation centers on the front haul fiber links. Then you process and aggregate the traffic and send it off to the mobile core on backhaul fiber links. For that to happen, we as an industry need to build a new cohesive, heterogeneous C-RAN infrastructure. And now we're getting into it. Once again, the concept of convergence, where we've got co-location facilities merging with fiber, merging with macros, merging with small cells, and at the same time being managed by an end-to-end software layer for command and control. So you literally have, in 5G, the only way it works is if all 5 pieces of the ecosystem work together. 5G is a completely different battle. A new space, power, and connectivity infrastructure to support 5G. It's a completely new war that we've begun to fight. It's all about convergence. So to wrap things up, the horizontal tower is really just a proxy for the convergence thematic in the industry today. As we evolve from the late innings of densifying 4G networks to the early innings of building ultra-dense 5G networks, it's clear that an entirely new infrastructure needs to be built to augment the work that you've all done so successfully over the past 30 years. We all have a lot to do and a lot to look forward to, and I look forward to working with you and other industry leaders to bring the 5G vision to life, town by town, city by city, and street corner by street corner. Thank you for the time today, and feel free to reach out to me at any time at rlachance@zenify.com with your questions or comments. Stay healthy and stay safe. Thank you. Bye-bye.